Space is a place that's rich in discovery. And I believe that nature has a vivid imagination, more so than human beings will ever have. And the only way we will find out what she has in store is to seek it ourselves. And that's one of the fundamental driving forces for doing exploration and doing basic science. We have an orbital facility now called the space station. It's still under construction, but we can do science now in space in a manner that's commensurate with how we do science on the ground. By that I mean science on the ground. We typically have a mix of programmatic science, which is well-planned, well-thought-out science. It justifies your presence in the laboratory. But at the same time, you've got human beings working in this laboratory that are thinking and scratching their head about what's going on in the course of doing the programmatic science. And they come up with new ideas, and then they charge off on some of these new ideas since they're already there and they got the facilities. And I call that science of opportunity. And that's the discovery science. And we can do that on Space Station now. And what I'm going to talk about here is some of the science of opportunity that we did on Expedition 6. And my commander, Ken Bowersox, he came up with the term Saturday morning science, which I thought was a good term so that folks would not confuse our science of opportunity with the programmatic science that was going on at the time. Here we're making the thin film simply by sticking a wire loop into what I call a two-dimensional beaker, which is just a food container cut off and filled with water. And here's some food coloring added to these films. And notice that motion is not very prominent unless you blow on it. And then you can get the fluid to move, and then it stops quickly. Here are tracer particles of mica flakes, 5-micron diameter mica flakes. And you put them in the film, and you get it rotating. And there's a soldering iron stuck on the side, and you can see convective motion going from surface tension gradients caused by the heat. And you can see the fluid moving, convecting. And here you see fluid convection caused just from shining a flashlight on this. And this is really what brought the Marangoni convection to my mind. Here we see sodium chloride crystals growing with time-lapse photography in one of these films where the growth direction is basically restricted to a plane. And here's some of the results, crystals upwards of a centimeter on an edge. And then you can reach in with a cannula and you can extract your seed crystals. And then we even showed that shining a flashlight on this system generated enough heat to cause a convection to occur. And it's just important to show that if you're doing experiments in a reduced gravity environment, you need to be aware of some of these subtle effects, because you may be doing a diffusion experiment and you shine video lights in your system so you get good video, and without knowing it, you might be driving Marangoni convection and turning your diffusion experiment into a convection experiment. So let's roll the next section of film. So there's a sphere, and a tracer droplet was introduced, and it makes a vortex ring. Now here's a sphere, again, about 3 inches of diameter. You put a bubble in the side, in the center, and now you inject droplets in the bubble. And look how they bounce around. It's like a three-dimensional billiards game. And this was something that just made my jaw drop. I had no idea that you could entertain a system like this, where the droplets bounce around, 5 to 8 collisions, and then part of the mass of the droplet will get transferred through the interface. And I'm still scratching my head as to what exactly governs the interactions here and when mass transfer goes across the interface. Here's a droplet that was introduced, so it rolls around on the interface, and these droplets will just scoot around and scoot around and scoot around for maybe 45 seconds to a minute, and then they will exchange mass. And a question arises, is this sliding like a hockey puck, or is it rolling like a ball on the floor? Boom, there you go. It decided to transfer a little bit of mass. And I think this might have some relevance for what's happening inside of clouds in thunderstorms. Now here we have some food coloring, and this shows what the fate of the part of the fluid that gets injected into the surrounding liquid is. And it generates vortex rings, little donuts there. Watch for this next collision. Boom, it transfers mass, it makes a little vortex ring in the surrounding fluid. And these kinds of things just made my jaw drop when I saw them. Now here you have this large sphere of water. It's about the size of my head, and gave an impulse on the side, And you see a variety of surface waves and body waves going through. They move around 180 degrees to the other side, make a big surface tension-driven spike. It collapses, sends body waves back down the other side. Hopefully they could be used as food for thought for other scientists that are doing research where they can see this dynamics without the complications of gravity, where students can look at these things and tickle your imagination and enrich your mind.